Good morning, section for the Kannada medium. I will try to use, all of you know Kannada? Yeah. Tomorrow itself is Namdu Kannada story. Everybody Kannada for the advance. Subhashigarannu ತಿಳಿಸುತ್ತಾ SVIT ಕರ್ನಾಟಕ ಉಸಿರಾಗಿ ಕನ್ನಡ SVIT ಕರ್ನಾಟಕ ಉಸಿರಾಗಿ ಕನ್ನಡ ಅಂತ ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಒಂದು ನಮ್ಮ ಕನ್ನಡ ಶುಭಾಶಯಗಳನ್ನು ತಿಳಿಸುತ್ತಾ ನಾನು I will start my talk on the design consideration for the advanced composites for aerospace applications. This is a very different. I will not go with whatever this title. I will go with what is required for our envoys. Like you are from which semester right now? Fifth. Already you studied mechanics of materials. Already you studied CAD. Then design, machine design, and all the important subjects already. I think you have studied. What is the role or significance of each subject in the design and development of our trainer as well as the fighter aircraft? I am going to cover in this particular session. Okay. Now tell me, what about the first this aircraft picture? This is aerospace. What is the name of the aircraft? Anyone having any idea? What is the name of the aircraft? Okay, leave it. What is the name of this car? Jaguar. Paka. Right of our Indian this one, Tata Motors. Okay. So, if you take this first aircraft, this is the F-16. I am not put our lasers, I am not put our some other aerospace products. This is the F-16 fighter aircraft from the Lockheed Martin, USA. Is it audible? Backside. Was it audible? Okay. Now tell me, who is our customers? If I am from the HL or I am from the SNO or I am from the some other our central bases like NAL or something. Usually, who is our customer? Indian Army. That means in broadly you can say Indian defense sector. That means Indian armed forces. Either it may be our Indian Air Force, Navy or our Army as usual. Okay. If they want to purchase these kind of aerospace products, what is the first step? If you want to purchase one mobile, what about your this one first approach? What you will do? What time? You mobile take some mobile ivaga. Budget, very good. Okay, next. If you know your budget, then go to 25,000 nange beku, 40,000 nange beku. What about your next? Processor. Matte? Storage. Atara small different parameters you are going to check. Correct? No one is going to purchase mobile like this. ಹೌದಾ ಅಪರೂಪ ತುಂಬಾ ಅಪರೂಪ ಹಣ ಮಾಡಿ ಅವರಿಗೆ ನೆಕ್ಸ್ಟ್ ವೆರಿ ರೇರ್ ಕರೆಕ್ಟ್ ಸೊ ಅದೇ ತರ when our Indian Air Force or Indian Army or Indian Navy they wanted to have these kind of aerospace products like 100 quantity, they need 100 aerospace products like this. So what about their first approach? What they will do? They will send us one important document, that is nothing but we used to call it as ASR, Air Staff Requirements. They are going to mention all the important parameters or specifications with respect to this aerospace products in that particular document. That document is nothing but ASR, Air Staff Qualitative Requirements, or in general we used to call it as PASQR, Air Staff Requirements or Plenary Qualitative Air Staff Requirement. Okay. When they want these kind of aerospace products, now what about their requirements? Tell me, how they are going to mention their requirements, in what way? Here role is more, our mechanical engineers role is more design, development of any automotive sector product, or it may be any aerospace product, or it may be you can take this plastic domain, or it may be whatever you are seeing, this home appliances. Our mechanical engineers role is very very important. Now tell me, what about their requirement? How they are going to mention the requirement? What about their requirement? Just less weight. Very good. This is the important parameter. One of the they are going to mention in that ASR, Air Staff Requirement, around 300 to 400 different parameters. In that major parameter, as a mechanical engineer, if I want to start the design of this particular product, where I need to concentrate on what are the different parameters we need to concentrate. That is nothing but first one is the weight. Very good, important parameter. Next, I need 2 more parameters. Sorry? But no, weight is integrated with the material. Okay, that is good. Material. Next. Cost. Okay. Power, strength. Okay, all these are related only. I need 2 more important parameters. Right? That is all once again comes into the design aspects. To make that one, what are the 2 important further parameters required? One is weight. Aerodynamic. Yeah, that means aerodynamic operational conditions we have to fulfill. For that, what are the 2 important parameters? All are from mechanical only. There is no any aero branch no sense. All are purely from mechanical. If this aircraft with a weight of around 10,000 kg, it has to travel from Bangalore Air Base to the somewhere Pathankot, Chandigarh, border of our India, Leh, Ladakh. Okay, what is required? If it wants to travel from Bangalore Air Base to the somewhere Delhi, what is required? Fuel, pakka. How you are going to estimate that fuel? On what basis? Yeah, exactly. At which speed this particular aerospace product has to travel? Around 2000 kilometers per hour. They are going to mention weight should not exceed 10,000 kg and speed should be minimum around 2 Mach number, or it will be 2000 kilometers per hour. With this velocity, how many hours it has to fly? What is that? Duration or endurance speed to car. These are the 3 important parameters we mechanical engineers has to analyze in line with the aerodynamic requirements. Huge role is there, mechanical engineers. Don't think whatever subjects you are studying from first semester, your CAD subject to the up to 8th semester your project. Huge role. Whatever you are studying, each subject as a code design engineer I am going to use. Don't think that simply I am reading and I am getting around 40, 80 or it may be 90 marks. If you are getting 90 marks, if you know if you doesn't know the particularly if you don't know the concept, no use. If you score 50 marks also, if you are very good in concept, that is required. Our mechanical engineers. Right now, if you see, lot of struggle is there for the mechanical engineers. You know, you have to compete with, you have to do the competition along with the big colleges, RB colleges, BMS, VIT, like that. So ultimately, when you come out from the college, ultimately all mechanical engineers are same only. They are not going to bother. He is from RB college, he is from the BMS. It will be there for weightage, and you are going to brief about yourself. But ultimately, when you are moving towards next step, ultimately what we are going to see, how best you are in your technical knowledge, how you are updated your technical skills, where exactly you are there right now as per the market requirements. Always our industries, if you see, right now a lot of industries are there in Bangalore itself, including startups, including like us. So many industries are there. Exactly what this industrial people are going to look by young Indians like you, with your skill, reskill as well as the upskill. How much competence you are having in your what you can call it the entire overall package. That is very, very important. That's why. So when we are going to see about the so ultimately these are the 3 important parameters, like particular aerospace product has to travel with a velocity of 2000 kilometers per hour continuously for 6 hours, and whatever product we are taking should not be greater than 10,000 kg. These are the requirements. Like that, apart from that, they are going to do lot of other parameters, like how seating arrangement should be there, side by side or one behind the other. That we used to call it as a tandem. What about the avionics systems? What about the radar? What about the EW suits? Right, you might have seen our Mark 1 products. We'll see a Mark 1 upgradation happened recently on October 17. We flown in front of the defense minister. That is fully updated one. Already 40 aerospace products. LCA we are handed over to our customer in the airports. After that, whatever around 200 quantity we need to supply, that is with highly equipped. That is no need to purchase from the other countries other than the engine. That is one big drawback is there, where you might have to look into those kind of aspects. Okay. Now tell me, once this is there, same thing for this automotive sector also. Some requirements will be there, market survey will be there. Based on the market survey, ultimately they are going to do some R&D, which type of product we need to launch. Right now it is there Jaguar. Beyond Jaguar, what we can do? If you see Tata Motors, that Gulf, Tata Indica earlier. Now if you see all Punch is there, Nexon, Harrier, okay, Safari, like that how they are launching. So ultimately like that, if you see Mahindra vehicles based on the same, the requirement and what about the condition, where exactly we are going to use. Okay. Now tell me how to begin. Now tell me how to begin the project. Already you know the customer requirements. It has to travel with a velocity of 2000 kilometers per hour. If these kind of aerospace products are already available in your company, already whatever customer has given, so as per the customer requirements, already everything is available in your company, but quantities are there, not there, 100 numbers. What about your approach? How you are going to do? Okay, thank you. What you will do? So already these kind of products are there, but stock is not there. So already these kind of aerospace products with a 2000 kilometers per hour continuously for 6 hours, weight is around 10,000 kg. Already we produced and we have handed over to our customer. Extra order we got 100. What is the big thing? We have to purchase the raw material, do assembly and hand over to the customer. If not, we don't have any product which is traveling with a velocity of 2000 kilometers per hour. We are having in our company or in our premises one aircraft which is traveling with a velocity of 2500 kilometers per hour, like our Su-30, which is weighing around 22 tons, 22,000 kg, and endurance may be around 8 hours. We are having higher end. One more aerospace product like our Piran Hawk, we are having, which is capable to travel with a velocity of 750 kilometers per hour, and weight is around 6000 kg. But what about the customer requirements? New. That is nothing but 2000 kilometers per hour, 10,000 kg. This one becomes the new project for the organization. Okay. At that time, how to do the project? So whatever design subject, whatever your basic concepts you have studied in your academics, those things only we are going to use. You might have heard these terms: conceptual design, preliminary design, detailed design. Correct? So if we are not having any aerospace product within this company, how to begin the project? That is very, very important, because ultimately what industry people will do, they will form one particular group of around 30 to 40 engineers, those who are dedicated to making this particular concept of that aircraft as per the customer requirements. Now tell me, what do you mean by this feasibility study? Any idea about the feasibility study? Before purchasing mobile, what you will do? You have the budget, you know, around 50,000 rupees, I need to take the mobile. I am going to take the mobile and decide matter. Direct over it, only over to what do you do? Research. Along with whom? Phone. In friends care. Correct? Illandre you want to shop go to ali inquire ಮಾಡ್ತಾರೆ ಮೊದಲು. Then you will think which product I need to purchase. That is nothing but feasibility study. Same thing in any industry. If you take any new product we need to launch to the market, or we have to start design and development that of particular product as per the customer requirement. If not available in our premises, we used to do this feasibility study. It is common in the case of satellites. If we are going to Chandrayaan 3 to Chandrayaan 4, what about the differences are there with respect to this? If we are going with some kind of rockets, so how to begin the new project, how to develop that particular compound, how to develop that particular entire as a product. So all those things feasibility study we need to do. What is that feasibility study? So what are the different aerospace products are available in the market right now? Like which are traveling with a velocity of 2000 kilometers per hour continuously for 6 hours and weight range is around 10,000 to 11,000 kg. What are the different aircrafts are available in the market? So a lot of literature is available. All the things we are going to take. Which type of engine they have used? What is the overall length of the aircraft? What is the wingspan? which type of kinematics they have used, what about the landing gear distance, nose landing gear to the main landing gear. So like that, all the important parameters we are going to note, and which aircrafts are already available in our premises with respect to the lesser weight or it will be lesser Mach number. All the data we gather. Based on that, we are going to do some kind of study. That is nothing but feasibility study. This is the role of all mechanical engineers. In this feasibility study, we are going to use almost all what are the subject we are studied during our academics. All the subjects. I will come to that particular point where exactly we are going to use each subject. What is the significance of the each subject? Okay. Now during the feasibility study, what we note all the things. How many days it will take usually feasibility study? You mobile purchase breaker hardly 1 or 2 days. You are not ready to wait with that money, 50,000. Correct? Somehow you need to take the mobile. Within half an hour or within 2 hours you will decide, and ultimately you are going to purchase the mobile. But what about the duration for this feasibility study? Yes, usually approximately 2-3 months. Exactly. It will be it is going to vary from the 3 to around 6 months. So what is the major significance of doing this feasibility study? Why we need to do? We can go directly to the next step, conceptual design. Why we need to do the feasibility study? We have to make the concept as per the customer requirements. So concept is nothing but he has given his all the requirements in the ASR in the form of a sum document. That document we have to convert it as a product. This is the important role of all mechanical engineers. What about whatever you are going to study in your higher levels, also 6th semester, 7th semester, what are the subject you are studying? All the subject you have to utilize properly to make this product. That means always whatever theoretical concept you are learning during academics, always be industry people interested to bring that one as a output. That is nothing but as a product. That is required. If you are reading and writing in the exam and getting the high score, no. Always whatever you are reading and whatever you are studying during your academics, all should, that particular technical knowledge you have to apply to make this particular product as a flying agent. Ultimately this object, whatever this object is, this object with this shape, you have to make it as a flying agent with a velocity of 2000 kilometers per hour. To make this one as a flying agent, this is not that much easy, not like a car. Not like a bike. It has to fly with a velocity of 2000 kilometers in the air. So ultimately, this is the feasibility study, but we are going to do whatever requirements given by the customer are feasible to make the product or not. He has given a number of parameters. Whatever he has given, if we are unable to make it, then what is the use of taking that project? Ultimately, we have to make the product and we have to sell to the customer as per his requirements. During the feasibility study, we have to study what are the things we can meet as per the customer requirements. What are the things we are unable to achieve. Those things we have to highlight. That means if we have said with 10,000 kg, that particular aerospace product has to travel with a velocity of 2000 kilometers per hour. With 10,000 kg not possible means, if you upgrade down, already you have received the money means, customer expectation will be that level only. He is going to say that by 2030, this particular company is going to hand over this aerospace product with a velocity of 2000 kilometers per hour and weight will be around 10,000 kg. But initially our budget is going 12,000 kg means, what about we have to say to the customer? At that time only we have to say, these many studies we have carried out. During the feasibility study, we come to know that with velocity of 2000 kilometers per hour, with a maintenance of 6 hours, it is not possible to have this product with 10,000 kg. There they are going to amend. They are going to amend means they are going to send one more version of that particular order with revised. That means around 12,000. Like that, whether we have to able to make that particular product or not, that is very important. That thing only we are going to study with this feasibility study. Once you know the feasibility study, as I said, there around 30 to 40 mechanical engineers will be there. This is very important point. In any organization, if you take ISRO, if you take NAL, if you take HAL, Well, with respect to the naval systems, I am not going to say I will aeroplanes. VL with respect to the naval systems. If you see the VHEL with respect to the mechanical components, any organization, if you take any products, especially our HAL, hardly 1 or 2 will be there from the other branch. Remaining out of 40, around 35% mechanical engineers only. Your role, you have to give the justification whether I am going to make this product or not. Even ISRO also, particular satellite has to land with a velocity of this much, and after this many days it has to be there at a particular orbit. Who has to analyze all these things? We mechanical engineers only. If you are going to make anything wrong at this particular what we can call it as that feasibility study itself, entire project, whatever you are going to launch in 2030, at that time it is going to fail. That means out of 30 members, one person is looking for the wing, one more person is looking for the fuselage, or it may be engine, or it may be some other components. They are going to study as a different teams during the feasibility study. So all these together we have to make one concept. Next step is the conceptual design. Conceptual design thing, but already 30 members are there. 30 members different mindset irutte. ನೀವು ಫ್ಯೂಸೇಜ್ ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಾ, ಫ್ಯೂಸೇಜ್ is what entire body of the aircraft. So you know what about the overall length, what about the overall width. So maybe around 10 meters length, width may be around 1.2 meter, height may be around 2 meters. So like that you are having that concept in your mind, but if you have to present that concept in front of all the mechanical engineers or all the stakeholders of that particular project, correct? So that is nothing but one more important parameters we are going to use, that is CAD 3-view diagram. I will come to that particular point. Yes, any problem there? Oh. See, conceptual design. Conceptual design is all the 30 members you are going to make the concept. If this particular aerospace product has to travel with a velocity of 2000 kilometers per hour, means fuselage length may be around 10 meters. Wingspan may be around 11 meters, height may be around 3.5 meters. What about the landing gear distance may be around 2.4 meters. So like that all concept you are going to make. That concept you are going to represent in front of all the stakeholders. Whether this concept is going to work or not. Same thing, whatever project you are making, your end of your academics, 7 semester and 8 semester, and many project at the 6th semester. Same thing, you have to take proper concept as per the industry requirement, and that concept you need to execute. Same thing here also, what we industry people are going to do. If you see here also, once concept has been made, then ultimately we are going with preliminary design and detailed design. This one I will touch afterwards. So to make this concept, what are the important things we mechanical engineers are going to look? Very, very important. If you see this particular slide, this is very, very important slide for the mechanical engineers. Very, very important slide for the mechanical engineers. If you see all the important terms here, you know materials, your materials engineering, material science and engineering subject, material science and materials is something, correct? What about the mechanics, kinematics of machines, or it may be DOM, COM, ultimately you know. Then what about the design, this particular term, design, machine design. Then what about the analysis? Analysis lab is there, I think Gamma lab is there for your 6th semester. Then what about the tooling? Your manufacturing 1 and manufacturing 2 subject, I don't know whether clubbed or say both are separate right now. Ultimately the manufacturing subject is there, manufacturing also we are going to use. Same thing, manufacturing, tooling, testing, your material testing lab, whatever tensile strength, whatever compression strength, whatever hardness, all the things you are going to check. If you see, to make these 100 aerospace products as per the customer requirements, we are going to use all these terms which are purely related to your academics, which you have studied during your academic semesters, correct? So all the knowledge we are going to utilize to make one end product. This composite product is nothing but you can assume that is the aerospace product. All the things are required. So I am very good in design, I will go with design. That will define your professional life later. But as a whole, if you want to become a package of mechanical engineer, I am good in mechanical means you should know all the subjects. That is nothing but technical knowledge. Very, very important. These things are. Now if you see this particular slide, as I said, I am going to make the concept after the feasibility study. Your concept may, you mark the concept, how you are going to represent the concept. Now tell me, if you are 30 by 40 site, if you want to construct the house, what is the first step? 30 by 40 site is ನಿಮ್ಮ ಹತ್ರ ನೀವು ಮನೆ ಈ ತರ ಕಟ್ಸ್ತೀರಾ ಆ ತರ ಇಲ್ಲ. What is first step? Plan. Okay. Plan for what? Don't say for constructing the house. Plan for what? For design. How you are going to represent your design? These all are very very important parameters. You can assume this one as your industry level questions only. Once you want to join any design organization, or if you want to join any manufacturing unit, or if you want to join any testing unit as a mechanical engineer after completion of your graduation. So, what are the plan? Next, someone told for design, how you are going to represent the design. I need core mechanical engineering terms. Yeah, that I will come to later. Exactly, by saying that you identified the topic you want to decide, that is your CAD subject. Why CAD subject is important for all the mechanical engineers. I will come to that point. Now design, how you are going to represent the design. How you are going to represent design. Design is nothing but this is design only. If you take this pen also design only. How you are going to represent design? Everyone knows design. Sorry? Exactly. Blueprint or plan of your house without dimensions, there is no any meaning. Correct? If you have made the plan 30 by 40 site, so ultimately how you are going to differentiate your kitchen, your bedroom, hall, puja room, how you are going to differentiate? With the dimensions. As a mechanical engineer, you should know these terms. Dimensions very very important. During the conceptual design, I have made the concept. This aircraft fuselage length may be around 10 meters, wingspan may be around 11 meters, wing area may be around 20 meters square. It has to lift 10,000 kg. So vertical tail may be around 2.5 meters. What about the vertical tail area may be around 2.3 meters square. So how you are going to represent all these things? What is the first step to initiate any design and development of any object? Either it may be pen, or it may be this remote, or it may be any car, or you can take satellite or aircraft. What is the first step in making design? That is conversion of that conceptual design to a preliminary design phase. During the conceptual design, you need to draw this particular diagram. What is this diagram? How many views are there? Three views diagram. This particular name of the that English is not okay. If you see this one, how many views are there? 3 views. The name of this diagram, 2D diagram, 2-dimensional diagram, is nothing but 3-view diagram. This is the first step in design and development of this pen, or it may be that Jaguar car, or it may be F-16 aircraft, or it may be our Blue helicopter or Tejas aircraft. This is the first step. Who is going to draw this one? Who is going to draw this one? Electronics engineer? Computer science? Aeronautics? Who? Your role. We mechanical engineers, we can say royal mechanical engineers, we. Don't worry about what is going to happen next. You are badly required to make sustainability in the manufacturing industry of this country. No doubt in that. Without mechanical engineers, the entire world is going to become rust. Don't worry about the jobs. 100% you are going to get the jobs. When technically you should be sound. Out of 10 members, who is answering very good? Those kind of candidates ultimately that industry people are going to see. Oh, he is good, something you know. Well, I can pick, if I train him, he is going to pick very fastly and he is going to contribute to the industry. No one is going to give you salary without you or this one. 100% I am going to give you salary means, what about my expectation? I am going to get more money. If you are not working for that, ultimately they are going to remove. That is only. If you are in government organization, something okay. But not like that earlier government organization. You believe or not, I am going at 6:45, going to home minimum 7:30. Daily. That is the scenario. All PSUs now working like that. No manpower, more projects. We have given the, if you see that our operation schedule, all those things. We have delivered the product as early as possible. Directly Defense Ministry is going to watch what is the stage of the aircraft, what is the stage of that particular product. Okay? Why you are going to study the CAD subject? For what reason? What is the significance of our CAD subject? Simply there is no front view, no top view, there is no side view, nothing like that. Each view is having its own significance. When you want to make this particular pen, no one will give you drawing directly to make this pen like this 3D model. It will go with 2D as well as 3D together. When you are viewing this particular object from front, you are going to look one kind of rectangle. When you are going to see from this one small circle, one more bigger circle. Correct? If you have to analyze as a design engineer, how you are going to convert this smaller circle to the bigger circle as a diameter of this particular pen. That is based on your how best you are in the CAD subject, how best you are in the machine drawing subject. This is the first diagram in design and development of any object you can take, whatever you are seeing here. If you want to make this particular chair, if you want to make this particular this one, how they are going to initiate or begin the project with this view only. Now tell me one more important question I am going to ask you. In this what is the front view? Now tell me what is the front view? Which one is the front? Front view? How many of you are going to say this is the front view? Raise the hand. You are all making. This class is entirely based on if you are industrial class. What we are going to use, same thing I am going to say in front of you. There is no any thing like extra, not like a academics. No. How industry people we are working, what we have studied during our academics or what you are presently studying right now. Front view, how many of you? What about you, Omar? How many of you are going to say front view in this one front view? Okay, I think 50%. Next, what about others? Which is the front view? How many are going to say this one front view? Sir, only? How many? One, this guy, good. Then no confidence others. Hey, just like master don't worry. Just your classes. I am going to say what we are doing. Why you are going to say this one as a front? What is the reason? Don't worry, you are here. Okay. Always, okay, good. This good, right? Always, how you are going to project the top view and front view? Top view is here, front view is here. Is it correct? Correct? Front view is here, top view is here. Correct? Side view is somewhere here. This is the top view. You project front view, or front view project top view. Okay, front view and top view should be one above the other. Now tell me which is front view and top view. How many of you are going to say this is the front view? Front view. You right angle. This is front view. Always front view. Aircraft thing is there. When you are going to see from the top, you are seeing entire aircraft. That is the moment. This is top view. This is projected from this. So this is the top view, this is the front view, this is the side view or end view. When we are seeing the aircraft from nose to rear, this is the end view. We are not going to take it as a front view. This is a slight gap between what we are studying in academics and what we are industry people are adopting this subject for development of our products. Slight gap. Where we industry people are like we are going to take the technical sessions like this to fill this gap. Okay. So all the industries, Airbus, Boeing, Lockheed Martin, if you take anything, SAR or it will be Rafael, anything if you take, all they are going to use same concept. This is the front view, just for this one, don't worry about that. This is for the front view, top view and side view. Now tell me what is the significance of all these three views? What is the significance of your CAD subject or engineering graphics subject? Why we need to put this one at the initial phase of the project or at the beginning of the project itself? Once your conceptual design you have made in your mind, all the concept you are going to convert it as this diagram. This diagram you are going to present in front of all the stakeholders. This is 2D diagram going to represent all the important dimensions of an object. Either it may be a pen or it may be a car or it may be this one or anything. First it will go with this particular diagram only. Now what is the significance of each view? Why this front view is required? Middle, sir. tell me what is the significance of this front view? What are the important dimensions I can mention? As I told, to construct 35-40 site, you are having blueprint, all the important dimensions like that to make any aircraft, to make any satellite, to make any helicopters, to make any car. This diagram will release from the design bureau. That is nothing but design organization. By whom? By all the mechanical engineers. What is significance? I can mention what is the overall length of the aircraft with this front view. I can mention overall length of the aircraft, top view also. I can mention what is the overall height of the aircraft from this landing area to the tip of the vertical tail, maybe 3.5 meter. What about, I cannot mention some of the dimensions in all the two views. Like I cannot mention in this, that is nothing but distance between this nose landing gear to the main landing gear. Why this particular distance we need to mention at this stage? Anything? Any idea? What is the entire weight of the aircraft? 10,000 kg. How you have to distribute that mass? Any important term for the mass distribution? Have you studied mechanics of materials? Strength of material subject? One important term. How you are going to balance this particular remote? If overall weight is somewhere front, if overall weight is somewhere rear, it will be like this. What is this? Center of mass. I need exact term. All the mechanical engineers are here. Center of gravity. Who told that? Center of gravity. Tell me, what is CG? Don't worry. Don't hesitate to answer next time. You will circle or definition. Don't worry that. Okay, here in Indian what you are studying, because this is very critical. If particular aircraft is traveling with a velocity of 2000 kilometers per hour, if the center of gravity is not proper, it will be in imbalance and this aircraft, how you are going, it is going, you might have seen here only, you are staying here only, you know Aero India very well. It is going like this, it is going like this, it is doing all the maneuvering. In all the cases, what about it should be in balanced condition? That pilot should have that mindset, I am going to control the aircraft. This aircraft I can control because CG is well within the limits. What is CG? Center of gravity. So particular aircraft, if you want to make, it has to fly with a certain velocity continuously for 6 hours, means that CG should be within the limit. Who is going to derive this CG? You mechanical engineers only. If you are deriving this CG wrongly, go on. The entire mass concentrated at a particular point of that particular object is nothing but a center of gravity. Entire mass of this particular object is concentrated at a single point. That is nothing but center of gravity. Somewhere it is there. If I lift from here, it will be like this. If I lift from here, it will be like this. I am going to lift this particular in such a way that at this point, from this x equal to 0 to the x equal to around 20 mm, this 20 mm is the center point of this particular object. That is the CG. Who has to decide? We mechanical engineers. Very important role. Whatever Mach 1 flown, just something. You might have seen news, SVIT aircraft, Hindustan turbo trainer aircraft. First flight happened on 24th of this month in our premises only. That entire mass and CG estimated by me. Entire. Since from 2012 to 3, I derived that mass. What is the overall mass of the aircraft and where that CG should be there. When it is flying, before that we have to weigh the aircraft and we have to confirm CG is here. Weighing when you will get, when object is there. But now object is there, all concept. Where our industry 4.0, where your machine learning, where your artificial intelligence, in line with our CAD tools, CAD, Ini graphics, your whatever CAD is, which one that? Solid edge or solid walls. So all the things we are going to utilize to make the concept. Very, very important. Don't think that whatever you are studying simply they have made the subject or simply it is there, some one paragraph, one chapter is there. No. All are very, very important for the mechanical engineers. If you are not reading now, when you are going to join the company after completion of your 8th semester, first time when you enter into the particular your cabin and after 1 week you will start your work and 100% if you are not good in technical knowledge, 100% I am going to say you are going to remember this term, you are going to open the book and you will start reading. No doubt in that. If you are not technically good. That is the pressure. Why? You are getting money. Now your parents are something fees they are paying and you are coming and you are studying, going. This is different. But at that time, company is paying money to you for your 8 hours of work. What about output on that particular day, whether you are given or not? They are going to see. If something they will tell to make this particular preview diagram, this concept has come, convert about this concept, somewhere Kiran is there, somewhere Akash is there, Akash convert this concept into a preview diagram. He will say that only your manager. You will not bother whether you know or you not know. You already you studied. Already you agreed for that particular package. You are going to get monthly 1 lakh rupees, means you have to do it. If you are not doing this, once again you will come to home, 100% what is the significance of what I have to do, everything you will start reading. That will come 100%. And reading is must, it is required throughout your journey or throughout your professional life to enhance your knowledge and to become good in your company or to become a good design engineer. This role is very big. Mechanical engineer's role is huge, very huge. I think maybe 1 or 2 years. After 1 second that boom will be there for the mechanical engineers. No doubt in that. Otherwise we are not going to manufacture good components. Otherwise we are not going to produce very good aircraft. Not possible. Okay. So like that, if you see this particular diagram, this particular diagram, this is very important. Now tell me, this nose landing gear, main landing gear, how much weight should be there on the main landing gear? 85% weight should be on the main landing gear. You might have seen commercial aircraft at the time of landing, any aircraft, at the time of landing, which wheel will touch first? Back or front? Back. So load on which wheel load will come more? Back. So 85% we have to make design in such a way that my center of gravity should be somewhere near to the main wheel. Correct? If something here, if you take these two are simply supported, if you take simply these two are just simply supported, just reactions, this is one line, here load is there, center load is there, and these are simply supported. If this is the middle, out of 10,000 kg, 5,000 kg will go, 5,000 kg will go here. If somewhere load is here, which is near to this one, arm is very near to this one, so ultimately more load will come. That estimation you mechanical engineers have to do with the help of this particular diagram. 15% load should come on this, and 85% load should come on this. To come 85% of the load, what are the things I need to keep and where exactly I have to keep? Everything you have to analyze with the help of this diagram only. At the initial stage, if you are going to make anything, your entire product, when you are going to fly into the air, it is going to collapse. That's why this preview diagram is very important. That is nothing but you are going to say, this is the particular this one, I am going to put load here, this whatever 10,000 kg load is there, that is nothing but your center of gravity, where CG should be there. How you are going to calculate the CG? What is the CG of each component? Cumulative effect of all the components, CG you are going to calculate, correct? Yes, to make one aircraft, how many components? Minimum 1 lakh. Minimum 1 lakh different components. All the components. If you take this particular pen, what is the CG of this one? This particular part I am going to manufacture this one. This is x equal to 0. This is x equal to 2 meter. Assume. This is x equal to 0. This is x equal to 2 meter. What is the CG of this particular this one? Button. It may be 1.9 meter. Because this is very small component. Weight may be around 20 grams. What is the CG of this particular whatever I am going to put? This is nothing but around 1.5 meter. What is the CG of this red? Maybe around exactly 0.5 meter. So like that I will calculate CG of each compound including 1 gram fasteners also. That much criticality is there in the aerospace design and development. If 1 gram fastener is going to attach somewhere here, this is 1 gram is there, this tip, what is the weight? What is the CG? I am going to know. Then all plus summation of all the mx by summation of mass will give the center of gravity, that is nothing but x bar. You used to call it as centroid. This is very important. Okay, like that each views are having its own significance. I will not take that much. I wanted to clear that only concepts with respect to the academic subjects. Okay, now tell me, what about this one? Why top view is required? Why top view is required? Tell me now. Wing span. Span also we can mention here. What is the overall length of the wing? Here also we can mention what is the overall length of the wing, but area. If you see this particular area, this area is very, very important. 20 meters square, 25 meters square. We are going to analyze the surface. A lot of comments are available right now. Whatever aircraft we are before manufacturing, we are doing everything will be digital. Right now you can see beautiful aircraft picture, ready to fly condition in the CAD model only. Therefore our role is more. We can proudly say mechanical engineer's role is more. Who will make the CAD model entire aircraft? We only. No electronics engineer, no computer science engineer. So we can see entire aircraft. Anyone, Air Force, Defense Minister is coming. Our product will come in 2030. Now we started the project. So how they are going to what we can call as evaluate your work? By seeing your CAD models only. This is the aircraft it is going to look. This is the car going to look in 2030. Like this we have made designs, like that we are going to present. Where it is the wheel. Wheel is somewhere around 1 meter from this one, and rear wheel is around 3.5 meter from the nose. So like that we will explain. Oh, they will say, oh, beautifully you made. And all options are there. You can make it as flying also in the CAD tools. Right now, lot of advanced tools are available. No, in future, no need to design any prototype vehicles. All the testing you can do with the help of CAD tools only. Directly, whatever production required, that production is start and hand out to the customer. Okay? This wing area height is very, very important. Wing area. This is the lifting surface. Whatever 10,000 kg mail hoga, 10,000 kg mail hoga, whatever that force is vertically acting about like this through the wing, that only is going to lift the aircraft. If 20 meters square is not sufficient, at that time that particular aerodynamics person will tell whatever this particular diagram you have made with the 20 meter square wing area, this 20 meter square wing area is not sufficient to make the aircraft. We have to increase the wing area. So that means 20 meter square to the 22 meter square you have to increase. Like that a lot of iterations will happen. That's why this is the significance of this review. Whether this 2D diagram is sufficient to make any aircraft, whether this 2D diagram is sufficient to make any aircraft, if pen is there, if this particular pen, when you are seeing from the front view one rectangular, when you are seeing from this front two circles, whether is it possible to make the pen writing? No, you have to fill all the refill everything. One volume is required. Conversion of this 2D model to the 3D model, this is one more important work of the mechanical engineers. One more important task of the mechanical engineers. Whatever you are seeing here, this volume is very, very important. When this volume is there, then only I can fly the aircraft. I can put engine, I can put the seats, I can put the required things to make it as a flying agent into this one. What do you mean by this particular outer boundary of an aircraft? I am not going to bother what is there inside, what is outside, how it is looking. This is nothing but numerical master geometry. Either it may be pen or it may be this car. Important mechanical terminology for that. Numerical master geometry. The outer boundary of an aircraft or outer boundary of an object, we used to call it as a numerical master geometry. This is very, very important. Important role of the mechanical engineers, this numerical master geometry. Any problem there? This guy. Any problem? Behind you. Any problem? Come here. Any problem is come. No issue, no? Then keep quiet, don't disturb. They are listening, not talking. Okay, see here, this outer boundary is very, very important. You know the CATIA tool? How many of you know the CATIA? How many of you know at least some kind of mechanical or modeling tools? Very good, modeling tools, at least your machine drawing subject to model. Okay? So those who are very good in surface modeling, sheet metal modeling, they can only make this outer boundary. Outer boundary is nothing but like our skin. How our skin is there. There is no any thickness for that. There is no any thickness. We used to call it as a zero thickness model. This is the next step to make any objects with respect to the CAD. Why this is very, very important in the case of automotive or it may be in the case of aerospace domain? Because we have to validate this particular object should be capable to travel with a velocity of 2000 km per hour. Correct? When it is traveling with a 2000 km per hour, what about the aerodynamic shape? If you see our BMTC bus, again how it was there? Very flat. Correct? Now if you see some kind of chamfer is there. So why that? To give the aerodynamic shape to the particular product. So ultimately this particular outer boundary is going to highlight whether this object is going to travel with a velocity of 2000 km per hour or not. That's why we are going to create this outer boundary with the help of some kind of CAD tools. CATIA is very good. CATIA is very good for the surface modeling. If you are good in the surface modeling, or if you are good in the sheet metal modeling, Boeing, Airbus, UTC Aerospace, they are going to hire you like anything. That means they are ready to pay you 30 lakhs as a fresher itself. Because this is very, very critical. When aircraft is going to travel with a velocity of 2000 kilometers per hour, slight deviation in the surface, something antenna is there outside, it is going to give, or it is going to create more obstacle for the airflow. It should not be there. If it is there, how best surface we are going to make? That's why this is one more important parameter for the us only. That means mechanical engineers only. Okay. Same thing in the case of car. If you see the car, if you want to increase the efficiency of that particular product, ultimately this aerodynamic shape is going to play important role. These all are important parameters for our mechanical engineers only. We are only going to do. We are only going to create these all particular what you can see outer boundary. Now you have created this outer boundary in the year 2025. When you are going to hand over to the customer in the year 2030, it is going to look like this only. This one you have created in the CAD model in the year 2025, but object, actual product you are going to hand over to the customer in the year 2030. But it is going to look same only. That's why numerical master geometry. We are not going to change any master geometry. You are now Teresidiala. So outer boundary when it is created in the year 1990. If you see that outside it remains same only. Inside lot of compounds we have put to enhance the. Why weight is going to play huge role? Why always we are going to bother about the mass? Why we are always going to bother about weight should be lesser than 10,000 kg? You believe or not, if customer Indian Air Force has given 10,000 kg as a mass of that particular aircraft, if we are going to hand over to the 10,100 kg, we have to, they are going to cut the money from whatever that order is there. If particular for this aircraft, one aircraft 100 crores. As per the agreement, we have produced this aircraft within 10,000 kg. If weight is going to rise by 100 kg means out of 100 crores he is going to cut around 2 crores. Why? Any particular reason for that? Rise in the weight? Why is going to deduct the money? Fuel consumption. Ultimately, 1 kg rise in the weight is going to consume 1 kg extra fuel. How many years? How many years he has to fly this particular aircraft? Minimum 30 years. Whatever aircraft we are making or whatever helicopters we are making, the life of that particular product is minimum 30 years. Or 10,000 flying hours. Which is reaching first. Within 20 years we are going to reach 10,000 flying hours. So we have to stop the aircraft at that time. 8,000 hours we flown. But number of years, 30 years, we have to ground the aircraft. You might have seen our MiG-21 recently grounded. But lot of static life we have increased, that ultimately serve for the country more than around almost 45 to 50 years. But we increase every time we have increased the strength of the aircraft by giving some kind of support, some kind of stiffness, all those things. That is second part. Now if you see here this particular chart, highest what is the contributor? Fuel, 45%. If I am maintaining particular aircraft, so ultimately 45% of cost I am going to pay for the fuel. How many years? 30 years. 1 kg rise in the particular that aircraft weight, ultimately is going to consume 1 kg extra fuel. For 30 hours PS means if we paid this one around 100 crores, for fuel itself he is going to pay more than 200-300 crores. Correct? That should not happen. That's why always we mechanical engineers have to design in such a way that that particular object should be in optimum design. So that's why this is very, very important parameter. If you see crew cost, pilot weight, pilot whatever we can call it as salary and align port to 31%, and remaining maintenance around 22%, and miscellaneous is around 1 to 2%. Now tell me. So always to meet the customer requirements, we mechanical engineers along with the materials engineers, we have to think to make this particular tip of the pen refill. Which material I have to choose? This is very, very important. If this tip of this refill is going to deform when you are writing like this, at the first step itself, what is the use of this particular pen? No use. First thing, very important and significant parameter as a mechanical engineer, as a design engineer, I have to concentrate how much amount of load I am going to put while writing. How much amount of load I am going to put while writing. When I am writing, some kind of pressure is there, so at that time deformation happening means, so ultimately no use. That means we are not a good design engineers. We have to see which type of material I have to choose and what are the different loads are coming on that design. Real design will take place like that only. When you are sitting in front of the system, when you are making one particular part of that aircraft, you have to see where exactly that part is going to use. I am going to make this one, this particular part. This means I am going to press here something. So this one. That means it is under compression load. When I am going to press it, this is under compression load. You should know whether this whatever material I am going to choose, this is going to tolerate that compression load or not. Along with that, what about bearing stresses? Sometimes when you are writing, so a lot of pressure we are going to put, you should not break. So all the things as a design engineer, we should know thorough knowledge about the materials. First thing, if you want to become a good design engineer, especially most of you are thinking about the almost I am going to become a design engineer. No one will say I will go to the manufacturing sector. No one will say I am going to some kind of sales executive. Not like that. Almost all out of 90%, your 100 or 90% will be I wanted to become a design engineer. So if you want to become a design engineer or manufacturing engineer, both are same. Don't even bother about that. The role is a little bit different. But both design engineer and manufacturing engineer should know what is the material. What are the different material properties. Very, very important. If you want to become a design engineer, when you are making particular CAD model, in the CAD software, you should know which material I have to use. That's why material is going to be used. So here, different types of materials are there, metals. I am not going that much deep. Polymers, ceramics, composites. Right now, if you see our trainer aircrafts, what we Indian Air Force we using, most of the trainer aircrafts are from the metals. Aluminum alloys, 90% aluminum alloys, 10% other materials. There is no any composite material for the trainer aircrafts. Why? Why for the trainer aircrafts we are using metals or alloys, aluminum alloys only? Any reason? Less cost. That is the reason, less cost. If we are going with same trainer aircraft with composite materials, so ultimately cost will be very high. Okay, now if you see here, once you start your career, when you enter into, as you enter into the that particular organization, if that is the core mechanical domain, like it will be design, like it may be the software. Software is that is design engineer comes under software. If you are a design engineer or if you enter into any shop like manufacturing unit, first thing in your mind it will come by seeing something, which material is this. If you are rotating something in the CAD model, you will observe which material, what is the density of that material. If you are seeing in the shop some kind of aircraft model or some kind of aircraft panels, doors or something, you will know which material they have used for this. Ultimately it will come. So here any number of materials are there. If you see, all materials we are not going to use. Especially aerospace as well as the space sector is very, very critical with respect to the weight. Weight and mass. What is the difference between weight and mass? One and the same or different? What is the definition for the weight? Mass. What is W? Weight. Mass into? You actually. But as an industry, we are not going to bother. We are going to express, but if you go with the definition, basics, the G factor is going to vary 9.81. But here we are not going to bother in our organization also. Since I am weight and CG man, my duty is to maintain mass as well as center of gravity, inertia values also. I come to that point later. So we are going to mention weight, mass, same only. We are not going to bother that one, kg. Okay, but as per definition it is wrong. But in our document we will use weight, in our document we will use mass, same. So aluminum alloys, aluminum lithium alloys, nickel alloys, titanium alloys. These bead we are going to use widely. I am not going to go that much deep. If packages are there, this is FTP, entire thing I am going to touch more deep on this. So what are the different types of aluminum alloys? There are any number of different types of aluminum alloys are there. We industry people are going to use 2 series aluminum alloys as well as 7 series aluminum alloys maximum. If you see our trainer aircrafts, entire body is made up of 2 series aluminum alloys. I am not going that much deep with the 2 series aluminum alloys nothing but aluminum jotege ಏನು ಇರುತ್ತೆ copper as a highest alloying element. Aluminum 95% ಇದ್ರೆ ಅದರಲ್ಲಿ 5% copper ಇರುತ್ತೆ. That is nothing but 2 series aluminum alloy. All our entire our aerospace products are made up of, especially trainer aircrafts are made up of 2 series aluminum alloys. Okay? ಈ home appliances ಇರುತ್ತಲ್ಲ ನಿಮಗೆ ಕಿಂಡಿಕಿ ಇದು ಡೋರ್ಸ್ ಪ್ಯಾನಲ್ಸ್ ಎಲ್ಲ ಇರುತ್ತಲ್ಲ ವಿಂಡೋಸ್. So what which type of aluminum alloys? Any idea? Your curtain ಎಲ್ಲ ನೀವು ಹಾಕ್ತೀರಾ ಅಪಾರ್ಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ನೋಡಿರ್ತೀರಾ. So which type of aluminum alloys? You can see that stripe kind bars, rods or some kind of channels. ಯಾವುದು aluminum alloy? Mechanical engineers you should know. 6 series aluminum alloys. 6 series aluminum alloy ಅಂದ್ರೆ aluminum ನಿಮಗೆ magnesium ಮತ್ತೆ silicon ಮೇಜರ್ ಕಂಟೆಂಟ್ ಇರುತ್ತೆ. Okay, like that it is very required, badly required for all the mechanical engineers. You should know properties of each material. What is the density of steel? Steel density ಏನು? Anyone? Steel density. What is the density of steel? You are mechanical engineers, you should know. If you want to make any component, first density comes into mind. If higher density, weight will be very high. If lower density, weight will be very less. You should know what is the density of each material. Why always we people are telling about the composites. What is the density of the composites? 1200 kg per meter cube to the 1600 kg per meter cube. Lesser, almost around 6 to 7 times than that of the steel. What is the steel density? 8000 kg per meter cube. Wherever 1 kg of steel I am using, there I can use 3 kg of aluminum. Density of aluminum is 2700 kg per meter cube. If I am using 3 kg steel, ultimately my weight will go up like anything. So instead of 3 kg I can use the 9 kg aluminum. I can use 20 kg composites. That's why always strength to weight ratio. Strength should be very high, weight should be very less. That concept we are going to follow in the industry. You should know all these basics must. Since you are in 5th semester, you should know at least what is the density of aluminum. At least whatever components you are seeing in your surrounding, you should be aware. 100%, otherwise you are going to open the book and read after completion of your graduation once again. No doubt. It will be there. Okay? Now if you see this, like that n number of different materials are there. I am not going that much deep into this materials. If you see here, this fighter aircraft F-35, 5th generation fighter aircraft, one of the best fighter aircraft right now in the world, along with the Su-57 from the Russia. Su-57 and this F-35 is from the USA, Su-57 from the Russia. Right now we are joining Indians to this category by AMCA, Advanced Multi-Role Combat Aircraft. AMCA, that is there already. 5 prototypes we have to develop by another 2 to 3 years. Already fund has been released. Our design phase completed. Now we have to make the prototype. We have to prove whether it is capable to operate or not. So if you see all these panels, everything is made up of composite materials. This is acrylic. Where this canopy is there, we used to call it a canopy acrylic. Each part design. If you see this F-35, what is the weight of this F-35? F-35 weight is around 30 tons, 30,000 kg, all up weight. Empty weight is nothing but without fuel, without that guns, missiles, bombs, all those things. It will be around 15,000 kg. The under 15,000 kg can take with that. That means 15,000 kg bombs, 15,000 kg missiles, all those things it has to take along with that. With a velocity of 2,000 kilometers per hour, for example. So at that time, how robust your structure, design development should be there. That is very significant. If you see here, I am going to make this particular panel somewhere here. What are the different types of loads are coming? All those things we mechanical engineers should be aware, and we should be we are going to design as per the loads only. Got it? So if you see this aircraft, why always materials? As I told, the strength to weight ratio. Whatever here blue you are seeing, this entire blue is nothing but composite materials. That means if composite material I am going to use, strength wise it is very high, weight wise very less. If I am going to make the aircraft by steel or 10,000 kg as per requirement, it will become around more than 70,000 kg. If I am going to make by all composites, it is around 10,000 kg. If I am going to make all with aluminium, it may be around 30,000 kg. So wherever base, like that means you cannot use in all these places like aluminium. You can't use everywhere like composites. No. What about the engine? So ultimately high temperature zone. There we have to go with some kind of superalloys only. So like that, and you should be aware, if I am designing this particular part which is coming in the engine, if you are assigning material as a designer A, as a designer A, I am going to assign the material as a aluminium, but it is going at a temperature of around 1000 degrees Celsius. Whatever design you have made, that design is going to reject by the higher ups, because it has to go for manufacturing, and that manufacturing fellow is going to see, he is going to reject directly whatever you made compound, you assign the material as aluminium. This aluminium is not going to sustain 1000 degrees Celsius. He will revert back, he will reject your part. Then once again you have to redo. You should not have. If you are a good design engineer, you should think, if I am going to use this material at an engine zone, so ultimately which type of material I have to assign for my part. If you are in industry, independently you are going to work on around 1000 different parts. All 1000 different parts manufacturing, all 1000 different parts design, everything role is given to you only. That means you should be thorough in that particular parts design and development. Okay? If you see here, how design activities will start in the industry level. Not only with respect to the small company or bigger company, all the organizations they are going to follow this particular chart only. If I am going to make this aircraft, 100 aircrafts like this, how my design activity will start? If I am going to make this pen, how my design activity will start? I will manufacture first this particular this object, whatever this white is there, I am going to manufacture this particular as a part, single. This red, I am going to manufacture this separately. Then what about next step? Assembly. That is nothing but sub. This is part, small part. Some 2 to 3 parts together, I am going to make some sub assembly. Then major assembly. Major assembly is nothing but this one. Any number of assemblies together, we are going to call as a this wing. That wing is nothing but whatever aircraft wing you are seeing, that wing, that is made up of any number of assemblies. What about the testing? If that particular part is very critical, at that time we need to test. Here in this pen we see the critical part, tip of the repeal. I need to test that one, whether that tip of the pen when I am going to manufacture capable to take load or not, that whatever Pascal I am putting that pressure, taking or not. What about critical part, one more, this one, because fatigue light. N number times I am going to operate this one. If operating this one immediately it is going to fail, means what is the use? And one more important time, this portion of the pen where I am going to put the pressure. Each part I have to test with respect to the hardness, with respect to the tensile. Which subject you are going to use once again for material testing here. What is significance of material testing? If someone will tell, go and measure, lab is there, you just check the hardness. If you are not thoroughly know the concept or procedure to measure the hardness of this particular object, how you are going to check? No. That means why the material testing lab is there, why heat transfer lab is there, why design lab is there. Volume of the shop, vibrations, very important, vibrations, all those things. General bearing, is there no sir? Still is there sir? Slabs, volume of the shop, vibrations, everything. These things are very important. All the things we are having our well equipped labs, we are sending our designers, he has to check, he has to get the results. If you are not good in that, ultimately once again you have to go back and you have to study. That's why all these things are very important. I am not going that much deep. This is each slide is almost around 10 to 15 minutes. So this is the concept to make any aircraft. And how we are going to fly? First, when I am going to have the aircraft in my premise, this is the first aircraft. Before takeoff, this entire aircraft is going to, this entire whole aircraft, you can see full scale. As the entire whole aircraft we are going to test. Got it? So enter as a whole aircraft. This aircraft is going to fly next month or after 1 year. As per the certification policy, we have to prove this is capable to travel in the air. For that reason, we used to call this ground test. This entire aircraft will be under ground test. What are the loads are coming when it is traveling with a velocity of 2000 kilometers per hour in the air? All the loads in the hangar we are going to put manually with strain gauges and sensors, all those things. When you have made the design, at that time it should be in such a way that it should not fail. Got it? When you are testing in the hangar, at that time this real aircraft is going to fail. Means what about your effort for the 5 years? When you are keeping this entire aircraft ready to fly, keeping in the hangar, and you are assuming here load is coming, I am going to put the load like that, different places loads are going to react. When load we are fitting, automatically if the failure of this particular component happens, means what about the designer's condition? Who has made this particular part? Where is this designer? Why it has failed? So lot of questions will come. So this is the role of our design. If it is going to successfully fly in the air, who is going to get the credit? We mechanical engineers. That's why your role is very important in the design and development of any object. I am not going to stick with only aircraft. Either it may be car, or it may be some kind of aircraft, helicopter, satellites. Our role is very important. We are going to take the blame, and we have to take the success both. That is required. That is nothing but based on how best you are there in your technical skills. But lot of review will be there. They are not going to make this design simply if you say this thickness should be around 2 mm, I will make the part. No. Once you make the part, lot of review will be there. They will review, everything will be there. During review, your part should not reject. Like that, we should have our technical knowledge. Okay. So, wait. I am here for you only, not for my. I don't have any this one. For me, what will come? Nothing, no. For you only. Who are there last? You will feel this one any moment, not now. When you start doing your job, no. At that time, you come to know. I am taking this struggle for you only, not for I can wind up. Thank you like that. What is there? The only thing I wanted to say how we are best using our mechanical subjects to make the product. Okay? You will not get these kind of sessions. After your completion of your degree, you are going to pay 10,000 and 15,000. You are going to join the class. 100% I am going to say. That will come. No one is going to teach you without taking money. When you complete your this particular academics, if you want to learn something technical also, for class you have to pay the amount. At that time you will remember some of the important things in your life. First you should have the 3 important things. Your attitude. That is very important. Okay, if you are whatever your knowledge is there, if your attitude is not good, no use. Okay, I am getting lot of money, I am getting lot of salary, I am spending here means something I give to the society. Not like that simply I will come here, sir, will honor. Not like that. So anything, something will give to our students to motivate our students. How we industry people are using concept, not like that clap. Okay, don't do like this in any class, not this class. Without winding up any session, don't put the clap. The 10 fellows all read. Okay? Be this one like a good student. First, that is very important. Not like how much knowledge you are having. So knowledge is driven by your this one. How best you are there. What about your attitude? Okay? If interviewer anyone is asking questions, if you are telling everything, if you know also you are telling only, no one is going to take it. I am telling you these kind of sessions. If you join after your degree, 10,000, 15,000, you will pay and you will you will sit for that class. I will say, I am only charging sometime. Anything if I want particularly, I will ask 15,000 give me, I will take the class for one day. Simply I am not giving you this 2 hours class for suitability like that. Here for students, I wanted to share my knowledge. That's why I have come here. Not like that. Okay. So why I am putting this much effort for you only? I can wind up very easily. Sir, hand me everything. Sir, call me. So okay, I will wind up. Okay, thank you. What is going to happen for me? Nothing. Okay. So these are the very important parameters to become a good design engineer. How you are going to select your design? You are going to select your design with respect to these important parameters. If I wanted to make this particular tip of the refill, so what about the mechanical stability? I should know which type of material I have to choose. What is the ultimate strength of this material? What is the yield strength of the material? Do you know about this stress strain diagram? Stress strain diagram. Why stress strain diagram is important? Significance. If you want to become a good design engineer, first step you should thoroughly know the stress strain diagram. Which load we are going to use for the design applications? Either ultimate load or yield load. Which load? ultimate. So what is the difference between yield load? What is the difference between ultimate load? That is very important to become a good design engineer. Always we industry people are going to use yield load only, because once yield, after yield, plastic deformation. Before yield, that is the elastic load. So whatever load I am putting within the yield, it is going to regain its original shape. Once permanent deformation happens, means that is behind the yield. No one, if that material is having around 400 MPa ultimate strength also, we are not going to use. If that yield strength is 120, we are going to use that 120. Like that, these are the important parameters. So I will not go that much deep. Simply these are important parameters. If you are using that particular material under high temperature applications, if you see engine, you should know at what temperature I can use the aluminium. So aluminium maximum melting temperature is around 660 degrees Celsius. What about the usage? Without permanent deformation, up to what stage we can use? Maximum 130 degrees Celsius. Beyond 130 degrees Celsius, if temperature is there, we are not going to use the aluminium. Although it is clear for the 180 degrees Celsius, but we are not going to use. So those things we design engineers should be aware about. What is the material? What are the different material properties? When I am making one particular part, which type of material I need to choose, where exactly it is coming. Those things are very important for the design engineers. So these are the important material temperatures, all those things. I will not go deep. And always for our right now industry, we are looking for aerospace projects, composite materials. What do you mean by composite materials? Combination of two or more materials. But right now in India, no one is going to manufacture aerospace grade composite materials. I will quickly run. If you see here, one particular chart is there. If you see here, this is just like a paper. You can see here prepeg. This prepeg is nothing but just like a paper. Just like a paper of 0.1 mm thickness. To make any aerospace product, thickness of around 1 mm, we are going to add these papers, 10 papers. 10 papers are nothing but that is not papers. Carbon fiber reinforced prepegs. I will not go that much deep. This is best for the researchers as well as the faculties. That's why I have kept here. So ultimately, we Indians need to do a lot of research with respect to making this one. These prepegs we are going to keep on the mold, like this. How they are keeping here. Afterwards, it will go into the curing. Curing is nothing but this kind of room will be there. Oven will be there. In that oven, at a temperature from 100 degrees Celsius, we are going to keep it for a period of around 5 hours, 6 hours. At that time, we get one kind of rigid product, that is nothing but skin, or it will be some kind of compound. That compound we are going to use in the assembly to make the aircraft. This one I will not go that much deep, because I thought fully lectures will be there, faculty will be there. So this is for them R&D purpose. Finally, we will get a finished part like this. So if you see what are the different parameters, this is once again not required for it. This is all R&D. If I am going to vary the temperature, what will happen? If I am going to vary the pressure, what will happen? So like that, n number of parameters will be there. So these things, whatever you are seeing here, prepegs are nothing but some kind of a cloth. This cloth only I am going to keep one over the other, and ultimately it is going to become the part. So to make that part is very critical. We are very good in making the part. If you want to make this particular part, we are very good in making the part. But whatever raw material is there to make this particular part, we are importing from the outside. No one is going to develop this one in India. That is one big drawback. We are importing this kind of, you can see, prepegs from the Hexen, France. Lot of R&D is going on in IITs, ISCs. Automotive grade, no issue. This plastics, all those things, no issue. But only aerospace grade polymer composites, right now we are depending on the outside. Our NLEs are very good, but we are good in manufacturing. So still these kind of prepegs we need to develop a lot of things for the engineer. This one not required for you. This is once again fully R&D. I have made it for the research purpose for the faculties, those who are good in research. This is all those things I made because I can't take the data from the industry. So this is I made handwritten to explain how each layer should be there, where exactly there. This is not for you especially. This is very important thing, like how orientation we are going to make one skin of the composite like this. So what about the 45 degree orientation should be there, that threads or it may be 90 degrees should be there, or it may be 0 degrees should be there. So all those things are going to play a huge role to make the properties of that particular compound. That's why this is very, very important for the researchers. You will, I think after your MTech or it may be during your PhDs, you will come to know all these things. So these all are with respect to that only. This is a very, very important chart. Nowhere you will get this kind of chart. This kind of chart is available with some kind of high quality industries only. So what is the percentage of orientation? Like this, if you want to make this cloth, if I am going to make 45 degree threads, around 40%, 90 degree threads like this, around 50%. What about the strength of this cloth? So like that, to make the particular part, this orientation as well as the percentage of ply is very, very important. As a student level, there is not that much significance. So I will move with this slide. Then once again, pitch layer should be 10 layers are there. 10 pages I am going to put one above the other. Pitch 45 degree page where it should be there. 90 degree page where it should be there. 0 degree page where it should be there. So this is like that. This is very good for once again researchers. I will skip. So how ultimately the fracture happens? Some I think classes you might have heard during your something reading paper or by watching TV, all those things. How the aircraft is going to crash. So these kind of cracks will be there within that particular lamina or particular material. This crack is going to cause the failure in the entire structure. So this is not required for you. So ultimately, these kind of aerospace products entirely made up of composite materials right now. Right now, no one is going to use metal or some kind of aluminum alloys. No. Right now, around 80% people are using for the drone applications as well as the unmanned aerial vehicles. Around 80% we are using composite materials only. So now, role of the composite materials to enhance the properties is very, very important. That is nothing but how I said that 45 degree orientation and the percentage of the ply is going to play huge role. Right now, not required for it. That's why I am skipping. If you see this particular aircraft, entire this outside body is made up of composite material only. This is unmanned aerial vehicle around 2000 kg category. In future, if you see operations in those, lot of what you can say that war happened between the unmanned aerial vehicles only. So only you can see the Rafale and the Su-30 hours flown few of the aircraft, but maximum with respect to the unmanned aerial vehicle. Future will be entire with respect to the UAVs only. But still we require manned as well as the fighter trainer aircrafts also for some purposes. So this is how air intake duct we are going to design. This is purely design. This is purely R&D area, research area, especially good for the faculties. This is the air intake. If you see air intake, if you want to make that air intake part as a designer, mechanical engineers, you have to choose sequence in such a way that mid plane. This mid plane is nothing but 6 papers are there, means the 7 papers are there, means middle one, 0, below 3, above 3. Which one you need to choose and how you need to choose, like that sequence is there. So that is not important for you, but during design phase you are going to learn. Once you enter into the industry, some guidelines should be there. As per that guidelines we have to follow, and those who faculties are working in the composite materials, they have to follow these design guidelines. If you see, if you want to make this kind of object, where exactly which percentage flies and which angle flies, you have to put all those things are there. This is once again not required for you. And here important parameter as a mechanical engineer. If you see, when aircraft is flying with a velocity of 2000 km per hour or 1000 km per hour, or it may be 500 km per hour, then some kind of thunder or some kind of that rainy environment is there, means ultimately chances are there of getting this stroke. Correct? So at that time, your composite design structure should be in such a way that it should pass its entire electricity. That means whatever the thermal effect is there, that should be capable to transfer from one end to the other end. That means during design phase, if you have to take care, that material should be a good thermal conductor. But all the polymers, if you see polymer composites, are not a good thermal conductor. So for that reason, what you need to do, you have to think. Okay. So for that, in the real time industry, what we are going to do, we are going to do with the copper mesh. Top level layer always with the copper mesh. So lot of R&D is going on right now to avoid that copper mesh, because copper density is almost around 9000 kg per meter cube. So around, if you add the copper entirely surface of that wing, it will come around 10 kg. 10 kg is used weight with respect to the aerospace domain. So instead of copper mesh, what I can use? So like that, lot of research is going on now. IITs, R&Ds, IISs, they are doing lot of research. Instead of copper mesh, they are going with graphene layer. Graphene density, if you know, very less than 800 kg per meter cube. 9,800 kg per meter cube. Almost instead of 9 kg, you are going to get hardly 900 grams. That is the where we mechanical engineers need to concentrate more on the R&Ds, more on the new technology, more on the new concept. Okay. Now these are the important terms where we have to look into the R&D wise, research wise. If you want to do any project with respect to the materials, with respect to the design for your 6th semester as well as the 7th semester, you can look into this one. How I can convert graphene powder as a SVIT? Any machine I can develop for that? Like that you can think. Because graphene powder, if you convert as a SVIT, that is big achievement. Lot of R&D area research is going on in that particular area. Impact damage. If something I am going to throw, I am doing repair at the top of the vertical tail. Something hammer is going to fall on the fuselage of the aircraft. What about the impact damage? That means these composite materials are very, very poor with respect to the impact damage. How best I can improve? These are the R&D areas I am going to highlight for mechanical engineers. Delamination. 10 papers I am going to join together. Is going to we are going to fix it very rigidly. But after sudden usage, that paper is going to open like this. That is the thing with delamination. Out of 10 paper, first paper will be open like this. Second paper. So after certain 30 years, it should be like that only. To improve the delamination, what we can do? Like the interface. How I can combine two layers. Then apart from that, fatigue strength. To improve the fatigue strength, what we can do? We can be applied load. So like that, if you see, all these are the important research areas for our mechanical engineers. If you show interest with respect to these parameters, somewhere your profile will go and you will be somewhere. No doubt in that. Okay. With this, I am going to conclude. I have not gone that much deep. If I go deep, somewhere it will take another 1 hour minimum. So I am thankful to the entire team of this mechanical engineers. I am thankful to the HODs, sir of this particular department, and the principal sir of the organization, and entire whole management of SVIT for giving me an opportunity to share my words with you young minds. Okay. Always remember, do always hard work. That is going to give you some kind of success. Thank you, sir. Any doubts? Any doubts? No? At least something you at least how industry people are working and how mechanical subjects are important for the design development of any component. That's why try to read more. That is very, very important. Thank you, sir.
Maybe a last session from then we'll have a validatory and join our team. Okay. If you have any doubts with respect to the aerospace related district, you can write it here to other levels because we cannot get a chance to work in the internship in the chair and field. Father, mother, ಯಾರಾದರೂ ಕೆಲಸ ಮಾಡ್ತಿದ್ರೆ ಮಾತ್ರ ಕೊಡ್ತಾರೆ, ಅದರ್ವೈಸ್ ಯಾರೂ ಕೊಡೋದಿಲ್ಲ. ಯಾಕೆಂದರೆ they present as a concerned defense sector. They have a lot of parents are work ಮಾಡ್ತಿದ್ರೆ ಮಾತ್ರ ಕೊಡ್ತಾರೆ. What all. So last session is on joining process, that is called welding, advanced welding. What whatever the studying process you studied in first semester and third semester, the traditional kind of it. Okay, now the session, last session from Chandrasekhar sir will give more insight about the welding. Please listen to it. So what do you say?
Very good afternoon to all of you. I know, I can understand. Already at Chennai, but I am not going to take much time. As per the directions of your HOD, I am going to take only case studies, not in detail, because this is I have prepared for faculty members. It is a faculty development program, and moreover, this is an advanced topic in welding technology. That is a friction stir welding operation. How many of you are knowing traditional welding? Traditional welding?
What you see in workshop, right now?
Traditional welding or conventional welding process. Can you come up with limitations of that? Limitations of traditional welding operation. Then I will come to solution part. What for we need to go for advanced welding operation, and what is the beauty of the friction stir welding operation? Yes, please. What are the limitations or drawbacks of conventional or traditional welding process? Please speak out. Jane Bhattacharya has said it. Have arc welding operation, gas welding operation, submerged arc welding operation. That all comes under traditional welding operations. What is the limitations over that? Why we need to think of this kind of welding operation, solid state welding operation? Any idea? No? No? How many of you are knowing basic principle of welding operation, drilling operation? Basic principle of drilling operation. Fifth sem alli idira, third sem alli idira, ee maatadbeku. Maatadilla andre nanu mundike hogalla. Lenge mugibeku antandre maatadbeku. Simple definition I am asking. What is the basic principle of drilling operation? Drilling operation. What is drilling? Making a hole. What kind of tool you are using there? Helical groove tool. Correct. Just you assume there is no helical groove on its circumference. There is no helical groove on its circumference. It is completely flat. The tool is completely flat. Then what happens? If I am sending it to workpiece, work metal, what happens? Huh? What happens? Cracks. No. Drill bit mele, circumferential part mele, helical grooves illa. It is entirely solid. It is just like a cylinder. I am forcing that particular into workpiece. Then I will be giving a speed to that particular. What happens? Friction. Very good. What? Friction welding or friction stir welding operation. Basically, we will be taking consideration of friction. Okay, because of the friction between the tool and the workpiece, the welding operation will be obtained. That will be getting. That is friction stir welding operation. Under that particular category, today I am discussing this. That is friction stir welding operation. Correct? I am Dr. Chandrasekhar, working for Bangalore Institute of Technology, and I am representing Indian Welding Society. Have you heard of Indian Welding Society? No? Indian Welding Society is located at New Delhi. I am the representative from Karnataka. I am the only person representing Indian Welding Society from Karnataka, and from last 4 years I am the governing council member for Indian Welding Society. We will be giving some seed amount for the conduction of seminars, workshops for the institutions. Okay, if you don't know that, please go through that particular website, apply, and you will be getting the seed money for the conductions. Okay, And in this particular session, I will be taking related to friction stir welding operation. What is the basic of friction stir welding operation? Next to that, I will be talking about the case studies. Here, my first case study is with respect to friction stir processing. Then I will be talking with respect to dissimilar welding operation. Next, I will be taking multi-pass welding operation. Next, I will be taking underwater welding operations. All this, whatever I have listed in this particular group as a case study that cannot be done by using ordinary welding operations, traditional welding operations. Because of that, this will be at the front. This will be at the top when I am talking about the welding operations, right? And this is the introductory part for this. This one is new technology. Welding, friction stir welding is a new technology under the family of welding. But as years is considered, this is not recently established one. This was established in 1990s. 1991 by TWI, the Welding Institute from UK. So almost 35 years we will be doing trial and error. Now we will come to one stage, that application part. Now we will be seeing the friction stir welding operation in almost all the sectors, namely in aerospace sectors, in ship weldings we will be using this, and in automobile part we will be using this particular kind of technology, that is nothing but friction stir welding operation. And in this particular case, most important thing is this comes under the case of solid state. Solid state antandre whatever the welding process you are you are using, in that particular case, usually the material will be melted, correct? The material will be melted. When it is solidifies, it will be turning into solid condition, correct? In all the considerations, if you take the consideration of electric arc welding operation, we will be heating that particular material above its melting temperature. Then after solidification, we will be getting a weld bit, right? But in this particular case, this is an example for solid state welding operation. The material is heated above the recrystallization temperature but below the melting temperature of the particular material. Let me consider aluminum alloy. Let me consider aluminum alloy. Melting temperature of aluminum alloy is around 650 degrees Celsius. But in this particular case, we will be heating that particular material to the extent of 450 degrees Celsius. Then we will be applying some kind of pressure as well as stirring when it is passed, the solidification from the semi-solid to solid condition will be taking place. That is called solid state welding operation. Friction stir welding operation is an example for the solid state welding operation. Next, here the historical review or history of this. As I mentioned, this was invented in the year of 1990s, 1991 by TWI, the Welding Institute. Then we will be taking trials. We will be doing some trials. Now we are at this particular stage. From 2010 onwards, we will be applying this particular welding technology in almost all the applications, industrial applications. As I mentioned, now we will be seeing this particular welding in aerospace. We will be seeing in shipbuilding. In almost all the sectors, we will be having the application of this particular, and this welding operation is patented. If you want to use, you need to take the permission from the patented authority, right? Next to this is the friction stir welding operation. Exactly what we are going to do. Before to this, just I need to show one video on this. Then you will be knowing what exactly the friction stir welding operation is. Now, just you observe this video. This is what I am talking about. This is friction stir welding operation. In almost all practical applications, we will be using this. Here, this is the tool. Now, you see, this is the tool in this particular case, we will be pressurizing that in the vertical direction. See, this is the workpiece. Two workpieces are placed in its position, and we will be giving pressure as well as steering motion with respect to this particular. So, when we are applying steering action like a drill bit, when it is steered and the pressure is applied on that particular, the material fusion will be taking place. That is the solid state welding operation. I was talking about this. This is the specially prepared friction stir welding operation. In Karnataka, we will be having only 3 machines. One is at IASC. You can make use of that particular apparatus. The cost of this particular machine is was around 60 lakh, 70 lakh. So, in IASC, we will be having this particular machine, and PES University. We can see this particular machine, and now we will be using JT, that is there they are using vertical milling machine. They are converted the vertical milling machine into friction stir welding machine. By using the particular, we can able to do the welding operation up to some extent. I mean, there will be a restriction with respect to thickness of the particular material, right? And this is the commercial one. This is the specialized machine we are using for the friction welding friction stir welding operation. And this is the operation, this is the working. Here, this is the tool. This we call it as a pin and probe. This is specially prepared depending on the requirement. As I mentioned, in this particular case, we will be considering tool as a prominent, very important element for the output. Whatever we are getting, that we call it as a servant welding or defect-free welding operation. This tool will play a major role. And this is the initial point. At this particular point, the tool will make the contact with the workpiece. Then the steering action will be taking place. Once it is started steering, the material will submerge. Then we will be giving the movement. That we call it as a welding speed. So, in this particular case, this is moving from this location to this location. When it is rotating, this direction of the particular tool will also matter. So, for example, you consider it is rotating in this direction. This will be considering as an advancing side, and the opposite one will be considering as a retreating side. Advancing side as well as retreating side opposite to each other. When I'm taking the microstructural aspect, there will be changes with respect to the particular structure, because at one side the material pushing will be taking place, at the other side there is no movement at all. So, in that particular case, understanding of the microstructure is another very important requirement. And this is the free heating zone. Then we will be taking joining operation here. Then we will be moving in the backward direction or frontward direction, and we will be giving some time for the solidification. I mean, converting semi-solid to solid condition. Then we will be extracting that, right? And in this particular case, I will show you some here. This is the welded part. This is the welded part. This what I was mentioning, that this is the advancing side and this is the retreating side. We have started from this particular location and we have moved in this direction. At the end, the hole will be left. This is the ending of that particular. Now, if you consider this, we cannot identify this as a welded joint. It will looks like a single component. Both will be together, adhere each other in this particular case. And here I will be discussing some of the trials what we did at our center. In this particular, you can say by varying the various process parameters, we have conducted this. Out of this is the good joint and this is the sound joint. Here, this is the rejected one. Here you can observe there will be a longitudinal crack on the top surface of that particular welded part, and here also this is the rejected one. Here there will be a crack at this particular pin. This is also rejected one. Before going for this particular operation, friction stir welding operation, optimization of the parameters is very important. We need to go for optimizing the parameters. This optimization of the parameter which will be giving the better results at the end. In order to optimize this, we will be conducting trial set of experiments. Set of experiments by using various parameters. Generally, we will be taking consideration of DOE. That is, by using Taguchi technique, design of experiments will be taking. By taking consideration of DOE, we will be reducing the number of times. If there is no DOE, we need to conduct number of experiments like 1000 experiments, 2000 experiments in order to reach the optimization parameters with respect to welding process. So, in this particular friction stir welding operation, we will be taking consideration of various parameters that can be optimized before that particular welding. Next, this is all the fishbone diagram. In this particular case, all will be having individual influence on the particular weld quality of the friction stir welded joint. I am not going to discuss this. And this is what I was talking about. The tool what I am using for this particular, which plays a major role. In this case, you can observe this is the pin what is inserted into the particular material. This is a cylindrical tool pin, and this one is tapered one, and here we will be having a square tool pin, and this is the threaded one, and this is the threaded one. So, in this particular case, the steering of the material is basic one. Basically, steering of the material is basic one. Based on the steering, how we are getting the sound welding that will be defined. So, in this particular case, this should be considered. This profile should be considered for the evaluation process. And this is about the classification, different zones in that particular welding operation. Usually, when we are talking about the conventional or traditional welding operation, how many zones you can find? One is weld zone. Second is HAZ. What is HAZ? What is HAZ? Heat affected zone. Third one is base metal zone. Correct? Here, in addition to that three zones, we will be having thermomechanically affected zone. This is the fourth zone. One is nugget, or this also known as base metal weld zone. And next to this, we will be having thermomechanically affected zone. Next to this, heat affected zone, and finally we will be having a base metal zone. Each will be differed with respect to its microstructure. The reason is that here the temperature will be different. Next to that, the temperature will be different. Next to that, there will be a change with respect to temperature. Because of temperature affected, the microstructure will changes accordingly. Right? And next to this is all comparison between traditional welding operation and friction stir welding operation. As of now, I am skipping this. Next, these are all key principles what we need to consider. Next, this is the dashboard on the friction stir welding operation. As I mentioned, many things we need to control, many process parameters we need to control. All will be visible on that particular. That particular machine is running at that particular RPM, and welding speed of that particular process all can be controlled and all will be visible on the dashboard. Next, these are all the few challenges with respect to friction stir welding operation. First thing is that high strength alloys cannot be welded by using this particular. For example, you consider titanium, tungsten. In such condition, we will be facing some kind of problems with respect to this particular machine. And next, initial investment is obviously high. Compared to your traditional welding operation, this is quite costlier as initial investment is considered. Next is lack of experienced personnel. As I mentioned, this is a new technology. We need to train the people in order to work on that particular machine or process. So, lack of professional trainer or workers. Next, Thus are the solutions for the particular challenges. As I mentioned, we need to go for advanced tool materials for welding high strength alloys. Next, we will be having a real-time monitoring system. By taking consideration of this, we can eliminate or we can overcome from the limitations of this. Next, I am going to skip this. These are all the advantages and limitations, and these are all the sectors where actually we are using this friction stir welding operation. As I mentioned, now almost all the industries we will be having this particular kind of technology, that is solid state welding operation. Aerospace, automotive, shipbuilding and railway industries are finding applications of this. And these are all few live examples where we have used this particular kind of welding techniques in order to join materials. Next, some safety practices we need to consider when I am talking about the welding operations. And these are all the standards. Like other welding operations, we need to follow some of the standards. For example, if I consider ISO, that is the Indian International Organization for Standards, then we will be having American Welding Society standards, then we have European norms, then ASME standards. Like other welding operations, we will be considering for the friction stir welding also. Next, this is what I want to discuss. These are all the case studies I have listed. Few of the case studies I have personally done at my work and my laboratory. And this is with respect to composite materials. Friction stir welding of ALMG Nano AL203 composites. Initially, we will be considering this ALMG alloy as a base material. That is 5000 series alloy. This application majorly we will be finding in shipbuilding industries. Generally, the hulls of that particular ship is made with this particular material, 5000 series. Particularly, I have used 5083 material for this particular. 5000 series will be having high percentage of magnesium. For example, you consider 5% or 6% of magnesium, that particular series we can call it as a 5000 series. In this particular case, Nano AL203 is mixed with that particular in order to prepare the composite. When I am talking about the composite, uniform distribution is our prime motto. Uniform distribution ultimately we will be reaching better properties. Correct? So, in order to do that, see, I am going for the DOE, as I mentioned, design of experiment by using Taguchi method. In this particular case, I have used 3 pin profiles. Out of these 3, and traveling speed as well as rotational speed I am varying by using DOE. Here, my task is to find out the optimum parameters for the particular welding. By using which parameters I can able to get the sound welds, I mean defect-free welding. So, in this particular case, this is the initial part, I mean before using the particular tool, and this is what I got pictured at the end of the particular operation. See, in this particular case, there will be a wear of that particular tool because of continuous contact between the workpiece and the tool. There will be a wear out of the materials. This is at the final, right? Next, this is very important. In this particular case, I am talking about the static and dynamic area of the pick. You know what is static area as well as dynamic area, correct? When the tool is in non-operating condition, whatever the dimensions are, or whatever the area I am calculating, that I am going to consider as a static dimensions. Now, in this particular case, if you take the consideration of the cylinder, thus there will be no change with respect to static as well as dynamic. When it is rotating, same diametrical tool will be into that particular material. It is steering. There will be no changes, correct? But in the second consideration, you take this. This is a square profile. Here 205 is the initial that we considered as a static diameter. When I am taking the dynamic, this will be 322. It means that this diagonal will be considered. When it is rotating, this diagonal should come into picture. Diagonal come into picture. As a rotation, it is going to cover wider area as compared to this cylindrical object. when we are taking consideration of wider area for the welding operation, obviously it is going to cover maximum the weld quality or weld coverage will be higher. Next, here see, this is the good weld or sound weld, I can say. In this particular case, this is the representation for the stir zone. SZ will be representing stir zone. Next to this, what I mentioned was thermomechanically affected zone is here, and this is your heat affected zone, and this is your base metal. So in each zone there will be a change of microstructure, correct? When this zone is considered, this is completely stirred by the mechanical action of the tool, correct? There will be a grain structure changes. The refinement of the grains will be happening. There will be changes at this zone. When we are moving towards the end, this is the thermomechanical affected zone. This is somewhat affected, but not fully. So the changes with respect to microstructure you can observe. Now you consider this. What is this? What is this? Here. What is this? Is this a good weld? This one is the rejected one. In this particular case, here there will be a hollow cross section. The reason is that whatever the pin I am using, that is unable to reach the end. Or I can say the penetration of the tool is improper. Penetration will not be up to the mark. Because of that, it left with that particular defect. This is what we need to do, optimization. For this, we need to go for optimization. We need to check which is the diameter or which is the length of that particular tool is suitable for the particular material or particular thickness. And this is microstructure. I took it from that particular. As I mentioned, this is for the stir zone, fine structure we can see. This is for the heat affected zone, and this is for the base metal. And this is EBSD. I took it from that particular. Here, this is for the base metal. You can observe 35.06 micrometer is the grain size, and this is for the second zone, that is heat affected zone, 25.25, and this is at the stir zone. Okay, 6.14. And this is my second case study, that is friction stir processing. Friction stir welding, friction stir processing are almost same. Here you have a look. In this particular case, we will be doing some grooves. We will be doing some grooves, or it may be some channel from like this. It may be channel or groove will be preparing into this particular groove. We will be filling the material. For example, if we want to go for composite material, here base material is your aluminum. Reinforcement material is B4C. Generally, B4C will be filled into this particular. Then we will be running with a pinless tool. Initially, we will be running with a pinless tool. What is the reason? Why we need to run with a pinless tool? Pinless tool. Because the scattering and expel of this B4C will be taking place. Initially, we need to cover this by running this pinless tube. After that, we will be going for friction stir welding operation. That is by using a pin tool, right? And this is also same thing. Instead of holes, we will be making the grooves. We are filling the material into this groove. Then we will be running with the pinless tool. Then with the pin. See, this is we have conducted at our institute. And this is the material Al2O3 I have filled into this particular groove. Initially I have run with this particular tool, that is pinless tool. Then I have used the pins. Two different pins I have used for making this welding, and this is the welded component, welded joint. And this is the next case study. In this particular case, you can observe here. What is this? What is this? Only one hole we are observing. It means that we have started from here, we have ended with this particular point. Only one pass or only one movement I am using for completion of this particular belt. That is single pass welding operation. Right? Here, how many pins are there? 2. It means initially I have started from here. Initial run, we have taken the tool back. Then we have started from here. Then we ran another pass. That is 2 pass welding operation. Then 3 pass welding operation. In which pass the microstructure quality is good and sound products we can observe. Last one. You mean to say in 3 pass. What is the reason? What is the reason for 3 pass? Look, hopeless to learn. You don't know what is the basic definition of welding. What is the reason? Why sound waves in 3rd category? Why not in 2nd category or in 1st category? As the movement of the pin repeatedly on the particular, there will be a refinement of the grains. Correct? Grain structure will be refined. When there is a refinement with respect to grain, obviously it will be affecting on the properties at the other end. Right? So, because of that, at this particular, we will be getting better results. Here you can observe, this is for the 1 pass, this is for the 2 pass, and this is for the 3 pass, and this is for the 4th pass. In this particular 4th pass, by comparing all these 3, I can say that there will be a uniformity with respect to that particular structure. Right? And this is a 4th case study. This is very important. The reason is that in this particular case, one material is of our aluminum, second material is of copper. It is dissimilar welding operation. This cannot be done by using any other welding techniques other than this solid welding operation. It is very difficult because the melting temperature of this aluminum is different, melting temperature of copper is different. It is around 660 degrees Celsius and it is 1060 or 1070 degrees Celsius, correct? When we are taking different materials with different melting temperature, it is very difficult to attain semi-solid condition at a time. But it can be achieved by using this friction stir welding operation, right? Next, another very important and very interesting topic is underwater welding operation. Many researchers are working on this. Already we have the particular setup for the traditional welding operations, but we are trying for the friction stir welding operation here. In this particular case, this is what I told, traditional welding operation. Now we will be talking about this friction stir welding operation. Here you observe, this is just a laboratory experiment. Still, we are not into that particular. We are in the laboratory experimentation. We are setting 2 workpieces, and another very important thing is this kind of welding operation is only suitable for butt joint. See, this is completely filled with water. In water, we will be conducting this friction stir welding operation. What is the advantage of this? What is the advantage of this? What advantages we can see here? This complete setup, welding setup, is underwater. For example, you consider the ship is in sea. We need to repair some part of the ship. In such conditions, generally we will be working under particular condition. Right? What is the advantage of this? Cooling. Very good. Cooling. Next up. Okay, I am skipping that. It takes time. Here, you observe this. This will be your underwater friction stir welding operation, and this is friction stir welding operation. When I am talking about this PHA, this is preheated zone. In this particular zone, due to the water that will be acting as a coolant, because of that there will be a narrow portion, there will be a less preheated zone compared to this, right? If this is the condition, obviously that will be affecting on the weld quality. And this is, we have not tried this particular, that is carbon dioxide assisted welding. In this particular case, we will be using liquid carbon dioxide. Here, liquid carbon dioxide is forced to the particular working junction that will be acting as a coolant. When this is forced onto this, the heat generated at this particular junction due to friction can be minimized. Because of that, we will be getting better results. Here you can observe this is obtained from this. And now we are into the robotic field also. I mean, by using robots, we will be taking consideration of this friction welding operation. Here, this is the tool. Here it is attached to the robot end effectors. Here we will be doing the particular friction stir welding operation. One simple example I can say, battery housings in EV vehicles, that can be done by using this particular kind of robot assisted friction stir welding operation. These are all simple examples of that robot assisted friction stir welding operation. And this one is tube or piping welding operation. This is one pipe and this is another pipe. Here we will be joining two pipes together in order to make a single component. This is additional metal. This is additional one. We are keeping at the center. This is one piece. One more piece will be taken. Then we will be joining these two. This is center one is for only support purpose. Now, small to bigger range materials can be welded by using this friction stir welding operation. See, this is the setup. This is the head, friction stir welding machine head. Here is the tool. The tool will be in contact with that particular workpiece. This will be rotating 360 degree in order to make the proper welding. See, this is the welded part. This is the welded portion. Hello, last. This is the welded portion we are doing by using friction stir welding operation. Okay, right. Next is this. That is the friction stir processing of nano composites. Already I have told this. In this particular case, recently I am working on this. Already some set of experiments I have completed. In this particular case, I have used this HANPs. Nanoparticles I have used less than 100 nanometer. And by using this friction stir welding operation, the grooves are initially made. Into that nano powder has been filled. Then we will be running with pinless tool. Then we will be taking a pin tool for the final touch-up. Right? Here there will be a stirring action. There will be a stirring of the material, composite, nano materials into that particular. Ultimately, we will be getting as a composite material. This is the final product. This is the final welded part we got from that particular. This is again I have taken into consideration, that is the Taguchi method. There I have conducted 27 trials. Okay. Based on the design of experiments, taking consideration of 3 parameters. 3 by 3 orthogonal array I have used for this particular experimentation purpose. Then I have conducted this for 27 trials. You can observe 27 pieces are there, 27 weldments are there. Then I have tested for the properties by taking consideration of destructive as well as non-destructive testings. I will come to I have got the results, and in this particular case, this is the tool I have used. That is tapered conical tool I have used for the steering purpose. And I am going to thank CIT Coimbatore. Majority of the work what I have done is at Coimbatore Institute of Technology, and part of the work is at Annamalai University, because here we have limited sources, we have limited missions. Okay, we need to go for Tamil Nadu as well as Andhra. The majority of the work related to this friction welding as well as friction stir welding will be taking up. So, and PES Bangalore and Jyoti Institute. This is what I told. In Jyoti Institute, they have modified the vertical milling machine to the friction stir welding machine. And my testings, whatever the EPSD and all you observed, all testings will be done at IIT Bombay. And my entire team, I need to acknowledge my entire team, my research scholars as well as student team for their unwavering support for this particular journey. And thank you everyone. You need any clarifications, you can raise your questions, because this is little bit advanced one, not at your level, I can understand. And this is for the researchers. If you want to do any research work on this particular, or you need to write a paper, there will be a huge scope. Okay, because limited work has been done on this particular, there will be a lot of scope. You can work on this particular. Thank you. Any queries? Queries under Chappadena? Queries under Chappadena? Full burst agutidira. Okay, thank you.
Thank you very much. Thank you very much, Dr. Chandrasekhar sir, for a wonderful insight on welding. Actually, we had a privilege to publish some more than 6 to 7 papers with him. It's an honor for me also. Also, we have one more dignitary here, stalwart, Professor Ravindra sir, whom I am still working with polymer, and from Chandrasekhar sir we are working on metal matrix composite. Still today we are in the collaborative. Okay, still we are publishing the papers. Still we are dealing with many of the commodities. Always we have a discussion with advanced materials, all these things. Okay, so as told, it may be little bit advanced one, but try to at least remember some of the points. It will help you for our project. Okay, so we have come to the last end of the session. Now we have a small honor for our Professor Dr. Ravindra sir. Yesterday he was just because busy with some academic work, so I request sir, please join on stage. And one more thing, I forgot to mention, we have a student-driven club, RoboCell.
we are open to collaboration for any kind of research activities.